Alright, the warm-up. Evaluate the following limit. So the limit as x approaches -3 of this rational function, if you plug in x equals -3, you will notice that you will get an indeterminate form. On top, you plug in -3 for x, you will get -3 squared is 9. 9 minus 9, you will get a 0 over. And if you plug it in at the bottom, you will also get 0. So this is an indeterminate form. So we have to use something else in order to find this limit without graphing it. So one thing we could do is use some algebra to get around this problem of 0 over 0. So let's go ahead and do some algebra. So x squared minus 9 is a difference of squares. You get x plus 3, x minus 3. And at the bottom, we can do the x method. 7, the middle number goes at the bottom. Multiply the first number times the last, goes on top. And then think of two numbers that multiply to equal 6, add up to 7. So that would be easy. 6 times 1, 6 times 1 is 6, 6 plus 1 is 7. And because we do want to, there's a 2 in front of x squared, you want to divide by 2 your answers here. So 6 divided by 2 is 3. And 1/2, leave it alone. So we're going to have x plus 3 as a factor. And then bottoms up, 2x plus 1. And what we could do here is cancel out the x plus 3 and the x plus 3, leaving us with an equivalent quotient here of x minus 3 over 2x plus 1. And now we figure if we can find the limit as x approaches -3, if we plug it in, use the substitution method. And so when we do plug it in, it will give us -3 minus 3, and then 2 times -3 plus 1. Worked out, you would get -6 on top. And -6 plus 1 is -5 at the bottom, giving us 6 over 5 as our limit as x approaches -3 of this function. Okay, so let's now continue on with today's lesson. So today we're doing selecting procedures for determining limits. Lesson 1.7. What if we have something with radicals? We have a fraction here dealing with radicals. So as we do as the same as the other one and try to use the plug-in method, we're going to try and plug in x equals 4. If we plug in 4, we would get square root of 4 is 2. 2 minus 2 gives us a 0 over. Plug in 4 here at the bottom, you get a 0 over 0, which again is an indeterminate form. So we would have to use a different something else. And so factoring and what we did in the warm-up would not work in this situation. That's why we have to select the correct procedure. So what we're going to do is this. It's called multiply by the conjugate. So let's get the problem. And we're going to multiply by the conjugate of square root of x minus 2, which is square root of x plus 2. Square root of x plus 2. And you would notice that if we do plug in 4 into this right here, into the conjugate, you would get square root of 4 is 2. 2 plus 2 is 4. We get a 4 on top. And at the bottom, we get a 4 as well. So it's a 4 divided by 4, we get a 1. So we're multiplying it by 1, really. And so we're not doing anything other than just multiplying it by 1. But now we have to FOIL the top and see if something happens when we FOIL the top. Square root of x times square root of x is x. Square root of x times 2 is 2 square root of x. Negative 2 times square root of x is negative 2 square root of x. And negative 2 times 2 is negative 4. This technique works if we FOIL out the conjugates only. So at the bottom, do not multiply it out. Leave it alone. So you would notice this always happens with conjugates. So the middle cancels out, and we're left off with x minus 4. At the bottom, we have x minus 4 times square root of x plus 2. And now we can cancel out x minus 4 and x minus 4, leaving us with the limit as x approaches 4 from the left of 1 over square root of x plus 2. And now if we plug it in, we will get square root of 4, which is 2 plus 2 is 4, and it's going to be the limit 1/4. Okay? Okay, pause the video, work on problem number 2. Okay, now I can give you the answer. Let's go to problem number 3. So the theme of today is to times by the conjugate. So let's get started with times in it by the conjugate. Square root of 2 plus x plus square root of 2. Do the same at the bottom. Multiply the top, leave the bottom alone. So when you multiply it out, it would be 2 plus x. The middle will cancel out. So in reality, when you do the conjugate, multiply the first ones and then multiply the last ones of each parentheses, of the terms in the parentheses. So we're going to get negative 2. Leave the bottom alone. X times it by square root of 2 plus x plus square root of 2. On top, 2 minus 2 cancel out. X and x cancel out. So we're left off with 1 over square root of 2 plus x plus square root of 2. And we have the limit as x approaches 0. And now if we do substitute in x equal to 0 for here, we will get 1 over square root of 2 plus square root of 2. And 1 over square root of 2 plus 2 at the bottom, you got 2 square root of 2's. And that is the answer. Pause the video. Try this problem on your own. Alright, now I'm going to give you the answer. Okay, how do we solve complex fractions? Problem number 5, limit as x approaches 0 of this complex fraction. You notice that if we do plug in x is equal to 0, At the top, we'll get a 0. Then we're going to have 1 over 0's x minus 4 plus 1/4, which is going to be 0 over negative 1/4 plus 1/4, which is going to be 0 over 0. That is an indeterminate form. So we can go ahead and do some technique in solving. This is a complex fraction. You have to like keep it very organized here. We have x divided by the sum of two fractions. So what we want to do is have a common denominator here at the bottom. So you got x minus 4. So you need x minus 4 here on the right side, and x minus 4 here on top. The first one needs a 4 and a 4 here. Now we have a common denominator. So we're going to have x over 4 plus x minus 4. You can put parentheses if you want it around that. For right now, at the bottom you would have 4 times x minus 4. So like I just said, this is the fraction here. So you got x divided by this being divided by, so this is this. Let me write this down over here. 4 plus x minus 4 over 4 x minus 4. You can put a 1 under x. You remember from elementary school, keep the first, flip the second, and multiply. 4 x minus 4. At the bottom, well, you could already see that 4 and 4 cancels out. So you can have x goes at the bottom. Now we have x cancels with x, and so this gives us now a limit as x approaches 0 of 4x minus 4, which if we once you substitute it in, you get negative 16. Go ahead and do problem number 6. Let's do it together here on this one. So this is the one you need to, you have the subtraction of two fractions on top divided by x minus 2. So you need a common denominator here. So this one is a 2 and the second one is an x. So this is going to be 2x minus, no it's not, it's going to be 2. It's going to be 2 minus x over 2x divided by x minus 2. Here we can like factor out a negative, so we're going to get negative x minus 2 parentheses over 2x x minus 2. You can cancel x minus 2 with x minus 2. So we're going to be left out with negative 1 over 2x. X approaches 2. Now we can plug it in and we're going to get negative 1/4 as our answer. Okay, we are done for today with lesson 1.7.